I appreciate the fact that we have started this this presentation about something aspirational and exciting, which is basically returning to the moon, with the cold hard facts that this activity, from a commercial standpoint, has to take into consideration risk. It also has to take into consideration what would be some of the challenges associated with, although not referenced specifically, the availability of government as a partner, a reliable partner, which would imply also the reliability of government budgets and planning. I know with the new incoming Biden administration, there's already the paranoia that everything that was on the table 6 months ago with respect to Artemis may in fact be off the table for a few years. So this is not a risk-reward environment right now. It appears to be, from a policy standpoint, risk. But let's look more aspirational here for a second and take a step back. My training is as a lawyer and also as a finance person, so that makes me somewhat of a paranoid schizophrenic. And so when I look at something like this, particularly returning to the moon, the first thing I try to look at is what are the underpinning questions that we want to deal with. And these are the ones that I see in business cases. These are more formally presented, but on a sort of the checklist between, are you serious about wanting to do what you're doing, or do you have something that would be closer to a sustainable business case in 2021, 2022, 2023, and on. So when we say we're going back to the moon, government, we know what they mean, but what would the private sector be talking about? Is it orbiting around the moon? Is it on the lunar surface like a lander? And which side of the moon? Chinese are on the dark side. That creates serious communications challenges unless there's some additional infrastructure to rely on. Are we there for the interim or permanent? Are we going to build off of landers that are only there on average about 8 days? Or are we going to be looking at building something more like Artemis, which would be a longer term habitation? Who's leading it? What's your schedule? This is certainly, from a finance standpoint, important, because these kind of projects are capital intensive. They're long lead time and long lead time to revenue. Those are basically three legs that have to be balanced in planning. You need a lot of money up front. You need it over a period of time. And you're not looking at, even with pre-subscription, which is a promise to pay, anything relative to revenue coming in until you actually deliver the product or the service. How are you going to do it? Landers, modules, they all have a whole variety of different challenges associated with them. And then finally, are you going to be public dependent, private dependent, or, as been discussed previously, public-private partnerships, which quite candidly are only as strong as the public part. The private part is one where it's only going to attract capital if the public is there. The public can proceed without the private investment on its own, if funded by the Congress, for example. So with those kind of Q's and A's, you then, let's go back to take one further step back, and that is, what does it take? Historically, we're going to the moon. Okay, in telecom, which is my business, the moon is really just the ultimate edge relative to telecommunications and communication services. So whether we're looking at Northwest Territories in Australia, or we're looking at a underserved or infrastructure light area in Africa, we're looking at possibly a lunar communications network. What are the things that a migrating humankind would need to be looking at in order to basically go off planet, and in this case, go to the moon? It breaks down into 5 general areas. One is we're going to need communications, and there is some priority to this. You really need to be able to communicate, and I use the American West as an example of migration off planet. For example, in this case, we had the telegraph, and then in the 21st century we have the cloud. We have the ability to do wireless in the right wireless environment, and the moon, luckily, is a vacuum. So for my business, particularly optical communications, it's a much more friendly environment than it would be with an atmospheric challenged area like the Earth. we have a need for habitation, shelter to survive and then thrive. We had sod houses in the West. Where are we going to find and who's going to come in and build the rad-free, maybe below ground in lava tubes, self-contained facilities? And can they be built with robotics versus what would be actual human managers or human involvement on the lunar surface? If they can, then robotics, using some of the examples of Rio Tinto in the Northwest Territories of Australia, consumes significant amount of bandwidth, which gets me back to communications. The ability to manage what would be remotely robotic activity to accomplish certain tasks. Transportation, we had the railroad. Today, we got SpaceX, we've got Ariane. Ariane has a lunar insertion vehicle with Ariane 6, it's planned. So there are vehicles here, but the price per pound of space is still pretty expensive. And so the ability to move people versus move stuff that you need probably is more near term. But when you move people, you add, as you all know, a different level of different challenge. And that's really common carrier rules relative to be able to protect people. Property rights. This is a big one. I put it down here as 4, but quite candidly, the arguments have already started as to who owns the moon. And you're going to get a business case that says, I want to do X. I want to extract minerals here. And somebody's going to say, you can't because you don't own that. And until that's solved, and I don't mean unilaterally, until it's solved as a community decision, as a lawyer, I can tell you that's going to be a problem. Because if you have a permanent habitation, you have regularly scheduled transportation with communications, and you're starting to extract things of value that you went there to begin with to extract, and you find out you have a challenge when you get back here to the Earth on who owns it, it's going to kill that. And you need to know ahead of time. That's a level of uncertainty you have to remove. Law and order. Law and order is simple. I put down here the 19th century cavalry outpost, but the true example of law and order, at least in the American West, was the Colt 45. Made everybody equal. In the 21st century, it's going to have to be a combination of international organizations, Space Force, equivalents in Europe, equivalents in other countries, and all cooperating and working together. That is to avoid what is a very bad history of the last 2 millennia on humankind moving into new territories where there is incredible riches available, turning us into a colonization process instead of into a nationalization or internationalization process. Then, of course, you have the basics. And this schedule I have here, by the way, there's a picture in the upper right-hand corner. That's my homage to our holiday today. The schedule we have here is based on a CommStar demand survey that went out to 3,000 folks back in September. We got about 300 responses, and out of the 300 responses, I'd say we hit about 90% of what would be those that have already put capital at risk, public, private, or both, in terms of programs. And a number of those were mentioned, programs were mentioned in the last 2 speakers. The migration process historically has been led by explorers and pathfinders. Well, in this case, 21 to 25, it's landers, and more landers. 8 days, 6 days, capabilities, payloads that do a variety of things on a small scale, admittedly. Based on the responses around 2024, and we've tried to take Artemis out of this and government-funded programs out of this, to 2030, we're seeing an uptick in interest in bidirectional communications, particularly on the lunar surface or around the moon, like Moonlight and CommStar. Transportation, there are now plans for different types of transportation vehicles that, assuming that the cargo requirement is there, which leads back to habitation. We have Artemis and we have Outpost, but the long-term habitation activities, for example, would be United Space Structures, USS, which is looking at basically developing structures, living structures below the surface of the moon. Mining resource and development investigations, those are landers first, and then there are actually robotic activities for deeper scale. and then logistical services, which are ultimately going to have to be done, as it was mentioned earlier. You have to grow, find, deliver, process, and supply for lunar activity on the moon itself. If you're continuing to wait for the wooden ships to sail to the new world, you're going to find yourself like Williamsburg in Virginia to have dying times where people are actually not going to survive. Security is important, as is the military aspects of this. And then onward, permanent settlements. Where? Meaning, if everybody is landing in 15 or 20 different places because they just want privacy, you're not going to have settlements. You're not going to have communities. You need to cluster around something, and that really is a role government could play. If not, then it's going to be settlements, and they're all going to be disextended, and the only way to save them relative to their growth would be communications on the lunar surface or through a moonlight orbiting constellation with a space relay through a satellite system like CommStar. Industrial development, it's going to go where the products are. Does that mean they're near the settlements? Maybe, maybe not. But if they're not, then you have to be able to get it to the settlement. Scientific investigation and security, the same. The good news is that based on the survey and the economics that were being put out, it reinforces that there is an acknowledgement of risk, and there is also an acknowledgement that there is capital flowing into what would be common sense, early stage, step-by-step evolutions off the planet to the moon, where it can be translated into return. Brief 1-minute note on CommStar. This is a lunar relay system. It's at L1. It's a network access point located for everybody. This is our contribution to the communication side of it. It connects to laser light for distribution on the Earth, as well as a partner, Access.Space Operations. I'm not going to go through these. They'll be in the slides that Tony will provide you. But the point being is that, as our previous speakers had said, you got to balance risk reward. You also have to balance who your partner is, but you have to build in an evolutionary sense on things that synergize not just what you're doing, but what somebody else is doing, as a way of building that infrastructure and also that capital return potential that would make, in the near term, I mean in the next 10 years, something that would be attractive to invest in. Thank you all. Yeah, this is Bob. I think this is a preference, obviously, and a prejudice, but I think it starts with the first impact of lunar activity is going to be in the communications area. We're finding that we've signed up, CommStar has signed up now relationship with all the CLIPS partners in some form or another, and have also begun the process of dealing with the longer habitation. And in creating what would be, to answer your question, Tony, about how do you finance something like this, you have to show the revenue potential against what would cost. CommStar's capital strategy, which I'm not shy to mention, is that the first 5 years is going to be basically a loss leader if you're just relying on communications, based even on the missions that we know are going to be there. The second 5, the bandwidth consumption we estimate on the moon will go from megabit traffic to gigabit traffic to petabit traffic. And in the last 5 years, because it's a 15-year life, is going to go to something more analogous to what we see now here in the cloud with it, which would be exabits and potentially zetabit traffic because of the heavy reliance on robotics. So if you can survive the first 5, then you're going to make it the rest of the way. And I think that's true of habitation. There's got to be some way to survive the first evolution in order to make enough stability to be able to survive the next iteration. And it's probably true of every one of those elements of habitation, communications, transportation, et cetera. And that's a role that government can play. We don't have any government participation in our program, but that's because the government is stimulating the users, meaning the landers. If they weren't, then I think the landers themselves would find it very difficult to be as robust as they are right now.
Bob raises a really important point that I think we have to think through a lot. And I like I like your capital plan. It's one of the most logical I've heard.
Yeah, I think. Go ahead,
I
Bob.
appreciate our first 5 years is this is a large satellite that we have planned. So consequently, as with other types of projects, what else can you do with that infrastructure beside the logical part, which in our case is a data relay satellite? Is there anything else you can do with it? And the answer is we have found that it also sits at 200,000 miles away from the Earth, but it looks back at the Earth. It's all line of sight to the Earth. So it has a high degree of possibility to be a hosted payload platform. So you put hosted payloads like situational awareness, PNT, et cetera, all looking back at the Earth. That's a secondary line, but that could be your primary line of revenue in your first 5 years, with comms being your secondary. Mm-hmm. And then as those hosted payloads either die off, wind up, or program, end, you've now bridged that gap between the infrastructure you expect to develop on the moon to, in fact, infrastructure and users that are there, and the payloads become then a secondary part of it. That's at least the plan. It's still a couple of years before you do it, but my sense is that there are other plans like that if you can look at what else you can do while you're doing this, like the landers, you're carrying payloads. And so the payloads are really the ones that are paying the freight, literally. Mm-hmm. What are the different payloads that they're doing that you can diversify your risk? And I think Astrobotics and Maston and Intuitive Machines are thinking that way, that they're just not they're not a truck driver. They're looking at other ways of mitigating the risk.
From Vincent. Vincent, any inputs about GPS or 4G, 5G on the moon? And so see the latest announcement from Nokia. What milestones and what timescale?
The future of 4G, 5G, I have to admit to you, it's really more realistically 6G. That's what the Chinese are working on right now. But for all of our benefit, it's just microwave communications at the higher bands. What is the future of that on the moon? It's got a terrific future. It's efficient in a vacuum. From a transportable standpoint, it's probably more efficient to use on the lunar surface, and what we used to call a repeater network. So if you again, the only basis we can kind of go off of what worked on the Earth, and is it transportable, transferable as a concept and architecture to the moon. So if you look at where wireless came from and analog to digital, et cetera, it started with circles of service. In other words, you got a license in, say, downtown New York or in London or somewhere else, and you built an infrastructure, partly because of cost, partly because of demand, partly because of revenue in that particular location. So on the moon, can you designate what would be an area where people are clustering or robotics are clustering? And then you say that's a circle of service. And then now you have customers, potential revenue to justify the infrastructure to be deployed. This is a little bit more cost effective than just throwing the idea out, which is ridiculous, that we're going to build a Wi-Fi network all over the planet. All over the moon. It's going to start in a circle of service around paying customers or customers who need communications horizontally on the lunar surface that then go to a hub that are backhauled. Someone else had asked, what can Astrobotics and Maston do in addition to the other things that they're doing? Part of it is becoming part of infrastructure that does this sort of backhaul function. So that's 4G, 5G, 6G, and the ability to do what Nokia is doing, other than that being a demo project. I think it's going to be the private sector that leads the way, and it's because there's going to be a demand for the communications away from the landers that have to be able to cluster comms to get the data back. And they'll either get it back to Moonlight, or they'll get it back to somebody else, and then they'll get it hopefully to CommStar, and then we'll get it to the rest of the world. The investment model that we have in technology on the Earth today does not work for space.
It doesn't. For space hardware.
space hardware and ultimately space services from the hardware.
Yeah.
The evolution of seed to angel and seed suck all basically the founder interest out, and then you go to VC. They don't want to build anything of scale. They want to build a demo. They want to make sure that you can hand the demo off and then they flip it to someone else like PE to do the scale work. Everybody wants no risk, so they want the government involved, or Musk involved, or Bezos involved, or sovereign wealth funds out of Saudi Arabia. It does not work. There needs to be a new paradigm associated with how we do this, and it has to take into consideration the special economic challenges that you laid out with respect to hardware.
Right.
Hardware is going to be that's the sticky DNA that makes all this stuff work.
Mm-hmm.
And if you have to wait 3 years and finance your team through 3 years before you even get to a chance to be able to deploy it and make any money on it, it is a very difficult challenge. Unless you are a high net worth individual who has ability and access to capital that everybody else doesn't have. And if you really focus on lunar, my sense is that you're going to bootstrap your way into a variety of topics we've been discussing for the last hour. Government, public-private partnerships, They all bootstrap. At the end of it, you need an East India company, or you need somebody else who is saying, I'm doing it because I want to make money doing it. And the only way I think I can do that is I can basically create a special fund or series of funds that know the risk, can take the risk, and essentially can fund the risk in terms of the reward.